Hello everyone, welcome back to Tech Wisdom. This is video 4 of Homelab series, and today we are going to set up Samba. This is the application that makes your Linux server look like a shared drive to every device at home. With Samba running, your storage drive appears as a regular network drive on Windows, Mac and any other computer in the house. Think of it as a USB drive that is always connected. No plugin is required. Open File Explorer on Windows or Finder in the Mac and there it is. Drag files, copy them, save them, and it just works. This is how you load movies into Jellyfin and drop photos into Image and share file with everyone at home all over Wi-Fi with the local network. First, a quick choice. Do we need to run Samba inside Docker or install it straight on Ubuntu? Both works actually, and each one is better for different use case. The native install is older, tried and tested way. It connects directly to your Linux user accounts. Setting permissions is easy. You get all the Samba's good features. And this is a good choice if the machine is only for file storage or if many people needs their own private folders. Docker is new and simpler way. The whole setup is just one small Docker compose file. You can copy it to any server, and if something breaks inside container, your main system is not affected. You can even run 2 or 3 Samba containers on the same machine at once. This is good choice if you are already used Docker for many things like we do. So in this series, I will go with Docker. It fits well with everything else we are building with Docker. And from the user side, nothing looks different. The shared folders shows up the same way on Windows and Mac. One small note, if you ever need advanced features like connecting to a work network with Active Directory or managing hundreds of users, go with the native install instead of Docker. For the Docker setup, we will use a well-known image called dperson/samba. It is lightweight image built on Alpine Linux. It uses very little memory and start up fast. It is also runs on most processors. And here is nice part. With this image, you do not have to write a long config file by hand. Instead, you pass your settings as a short flag, and the image creates the config file for you each time it starts. 3 flags handle most of the setup. -U for users, you provide username and password. -S for shares, you give a share a name and point it to a folder. You can also control things like read-only access, guest login, and who is allowed. You can add as many users and shares as you need. Just number them like share 1, share 2, or share 3. The third setting is -G for global setting. Use this for extras like making sure the newer assembly protocol is always used. This covers the basic. Now let's start building. I'm going to use anti-gravity again to create the Docker Compose file. I know that looks like a easy way out, but there is a reason. Over the series, we will look at many ways to write and run Docker Compose files. So now, since this is just a beginning, I want to get things running without getting stuck on small details. So we will ask Antigravity to generate Docker Compose file for us. We will also ask it for a clear breakdown of the key Samba settings so you know exactly what each line does. I have typed the prompt into anti-gravity. Let us wait for the response. After a moment, it has come back with the full Samba walkthrough. Let us open it and you can see how detailed the response is. Feel free to read through it if you want a deeper understanding. Now it has not generated Docker Compose file yet, so I'm going to ask for that separately. And as you can see, it has generated the Docker Compose file in Samba YML file. The image and container name, you can see the volumes here. Below here are the username and password. You can change it if you like, but I will let it same. Now I'm going to copy everything from this Docker Compose file and paste into Portainer. As you can see, we have already Jellyfin stack. We will create a new stack and paste the contents in the web editor and give a stack name and then deploy. Wait for container to become healthy, and once it's a green, we can add shared storage as network drive. It have become healthy. Let's open my PC and from the menu choose map network drive, select drive name and the folder. I don't know what to add in the folder, so let's go back to our anti-gravity walkthrough and look for client connect part. And here it is. We have to put server IP and folder name and then enter username and password. Let's do that, and here it is, the shared folder on my Linux server. And as you can see, my Jellyfin anime folder, now I can easily copy paste my new data without opening my Linux server. And that's it for this video. Your home server now shares its storage with every device at home. The drive is just one click away from any Windows, Mac, and Linux system, and it runs inside a small Docker container, so you can take it to any machine. In the next video, we will move into smart home territory with Home Assistant. We will get it running and connect our first smart device. If this helped, please like and subscribe. It really means a lot. Thanks for watching and take care. Thank you.